In this lesson, we will work with questions from Unit 3, Section 3.2, perfect squares, perfect cubes, and their roots. Our first question, if the volume of a cube is 125 meters cubed, what is the length of each side? So think of this one, which could be very similar to the square and its area. If a square has an area given, and we need to find a side length, you have to take the square root. Very similarly, if you have the volume and you need to find the side length of the cube, you will have to take the cube root. So in this case, the cube root of 125 is equal to 5 meters. You could use technology here to help you, or we could do a quick check. Five meters times 5 meters times 5 meters equals 125 meters cubed. And this check will help us prove that the side length of the cube is 5 meters. So our answer here is A. Next, to number 2, use prime factorization to determine the cube root of 3,375. So what we're going to do, we're going to start off with our prime factorization of 3,375. And we're going to decide what number to start off with. Well, since it ends in 5, we can start off with the prime number 5. 5 times 675 is our first level. 5 is already prime, so we can move that one down. Now we have to branch off to 675, that's not prime. Again, we can use 5. 5 times 135 is 675. Now our this level, 5 times 135 is equal to 3,375. Next, we'll continue on. 5 is already prime, 5 is prime. 135 is not prime. Again, we can continue with the 5 since it does end in 5 and using our divisibility rules. 5 times 27 gives us 135. We're going to branch off here again. We can bring down our 5s. 27, we have to use 3 and 9. Everything is being multiplied in the level. Now, 5 times 5 times 5 times 3 times 9. It's not quite there yet. They're not all prime. So we bring down our 5 for the last time here, and our 5 again, and our 5 again. 3 is already prime. However, we need to branch off from that 9 by 3 times 3. So just to conclude here what our prime factors are for 3,375, we have 3, so it's 3 to the exponent of 3 times 5 to the exponent of 3. Keep it in mind, if you want to determine if a prime factorization is going to be a cube root, you need 3 equivalent groups. Can we do that? Yes, we can. So the cube root of 3,375 is going to equal the cube root of our 3 equivalent groups. So in each group we're going to have 3 times 5 which equals the cube root of 15 times 15 times 15, which is going to produce an answer of 15. So the cube root of 3,375 is 15.